Alright guys, once again I welcome you to my YouTube channel. If this is your first time of joining me, please do well to subscribe and click the notification bell so that you can be alerted for newer videos that I will drop. Also, do give a like and thumbs up to this video. Alright, so in this particular lecture, we will be talking about the C programming, the introduction to the C programming on the ALS stats. That's the 0x00C hello world. Alright, now there are a few concepts that you need to look at before watching this video. I would implore you to reach out, try to download this PDF. Also, particularly, I would advise that you watch the videos titled Learning to Program in C Part 1 and Learning to Program in C Part 2. It is very important that you watch these two videos, very important, as they would serve as the basis to assist you to even complete your objective test questions and also to be able to go ahead with the coding. Now let us talk about the general requirements. Okay, so the general requirements that will be required for our C program, when we write a C code, we can use the VI editor. To compile our C code, we would use the GCC compiler. Also, all our files in the C, that is all our coding in C, must end with a new line. You must also ensure to add a readme file for both your repository and also for your the directory containing your project. Once again, I'll mention the importance of having the readme file. The readme file is supposed to give a general description of what your coding is all about. Okay, so also you should not have an error or any warning during compilation, and you are not allowed to use system. Also, when you code, you should use Betty style, and the checker would use Betty style PL and Betty doc. So this Betty style will talk about the coding style, while the Betty doc would take care of the documentation of your code. So it is important that you avoid using redundant spaces while coding. Now we would also be coding some shell scripts. So the acceptable editor is also the VI, VIM and Emacs, but I specialize in the VI because it's quite easy for me to use. Also ensure that all your scripts must be tested using the Ubuntu 20.04 LTS, and your scripts must be 2-line long, and all your files must also end with a new line, and you must ensure that your first line of code must be exactly the hash band. Okay, so we move straight quickly now to the task. Now for our first task, we have 0 preprocessor. So we are encouraged to write a script that runs a C file through the preprocessor and saves the result into another file. The C file name will be saved in the variable $C file, and the output should be saved in the file c. Okay, so I'll go to my GitHub account. The first thing I need to do is I will be creating a new repository, ALX. Take note that the name of the repository is ALX-low level programming. So I'll be creating that -low level programming. Okay, _1. Okay, so ALX-low level programming _1. Now I'll be using _1 because I already have a repository called ALX-low level programming. So while creating your own, this should be the name of your repository. But for the purpose of this tutorial, I will be adding _1 to, and then in the description of the repository I'll just write I am learning to code C. Okay, make it public, and thereafter just scroll down and then create the repository. Okay, my repository has been created. The next thing I need to do is to come back to my and launch my sandbox. Okay, after launching my sandbox, first thing I need to do is to change to the root directory. After changing to the root directory, I need to now clone the repository that I just created. So let me run through the process of cloning the repository once again for your benefit. Git clone https:// now I need to get my token. Okay, so I'll copy my token. Okay, after copying my token, paste that at github.com/ my username / the name of the repository, ALX-low_level_programming_1. Let me check to verify. ALX-low_level_programming_1. Good. .git. Enter. Okay, you would see it says cloning into blah 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 blah, remote repository not found. Okay, need to be sure that I wrote the name correctly. Okay, low level programming_1.git. Okay, let me just do this, copy this, then let me attempt to clone again. It's clone https. Okay, I'll need my token once again. Paste that at github.com, username, and then the name of the repository. Okay, so name of the repository, copy that. Okay, so after writing that, I have successfully cloned my repository. You can see cloning into ALX-low_level_programming_1. You appear to have cloned an empty repository. Okay, so if I do an ls, okay, so I would see the repository that I just created here. Let me copy the name because I'll be needing it. Okay, so I change my directory to the repository that I just cloned. Now inside this repository, I need to first of all create the readme file. So my readme file will be this way. Okay, so let me echo. You can use quotes, you can decide not to use quote. This is a repository on C programming language. You can use whatever you choose. I will put that into a file called readme.md. Good, you'd see the readme file has been created. If I cut the readme file to display the content, see it says this is a repository on C programming language. Very good. Now on my task page, inside this repository, I need to create a directory called 0x00-hello_world. I'll copy that using Ctrl+C. Then I need to make the directory called 0x00-hello world. The directory has been created. Let me clear my screen. Okay, so the directory has been created. Now I need to move into that directory that has just been created. Good, I am in the directory. The next thing I need to do is to create a readme file. So I'll call the readme file C hello world. So let me copy that using Ctrl C, echo, Ctrl AV to paste. I echo that into my readme. Oh, sorry, my sandbox closed. Okay, so give me a moment to restart it. Okay, so I have restarted my sandbox now, and I am finally in the 0x00 hello world directory. Now I need to create the readme file. So echo. Now I want my readme file to carry this content. C hello world. I'll copy that and I'll paste it here, and I'll put that into my readme.md. Okay, so I have my readme.md here. Now for our first task, which is task 0, we have been told that you need to write a script that runs a C file through the preprocessor and saves the result into another file. The C file name will be saved in the variable blah blah blah, and the output should be saved in the file C. So this is the most important thing we need, preprocessor. Okay, and take note that it is a script. Okay, so to write that script, we need the file name. So as usual, we use the VI editor. Okay, so VI, the name of the file, I to insert. We start our script with the hash bang. Now, how do we write a script that preprocesses? Now, if you have been able to look at some of the resources, you would see that to compile C code, goes through 3 stages: the preprocessing stage, the compiling stage, and the assembler stage. So you can break those stages. So we're trying to break the stages using the script that we're told to write. So to break the stages, this is the first thing we need to do. Alright, so usually to preprocess, we usually use the GCC. If you read the resources, you would know what it stands for. Now, in order to break the compiling process, we use the -e. Now, this -e or -e is the first stage of the compiling, which is the preprocessing stage. Now, what are we trying to preprocess? We're trying to process the C file called #C file. Okay, so that's $C file. Now, after preprocessing, we want the output to be saved in a file called C. So we specify using -o that the output should be saved in a file called C, small letter C. So this ends the code. We escape, :WQ to save and quit. Do not forget to set the permission of the file to executable. So you see we have our 0 preprocessor here as a script. The second thing we need to do for our task 1 now at this point. Now please take note that at every point in time you can add, commit, and push your code. Now I usually take some time to add, commit, and push because adding, committing, and pushing sometimes can be a very difficult or lengthy process. More especially if you encounter some errors. So I try to do at least 1 or 2 tasks before adding, committing, and pushing. Okay, so I'll do the next one, which says write a script that compiles a C file but does not link. Okay, so we're trying to compile this time around, and the output file should be named the same as the C file but with the extension .o. So for example, if the C file is main.c, our output file will be main.o. Okay, so what we need to do now is we use our VI editor once again to create the script. We get the name of the file, which is one-compiler. I Control AV that to paste. So I am inside the VI editor. I to insert. Because I'm writing a script, I start with the #bang. Now I'm trying to talk about an aspect of the compiling process, which is the compiler process. So that will give me -C to show that it's a compiling process. Now what am I trying to compile? This file called $C file. So $C file. Now I want the output to be stored in a file extension .o. So I'm going to now take note that the name of my file is one-compiler. Okay, so I'm just going to do one-compiler.o to show that I want the file to be stored in the output file called main.o. So I just use since my file is one-compiler, I'll just say one-compiler.o, and that automatically I'm done. Escape key, then :WQ to save and quit. Do not forget to set your file to executable. Do an ls and you'd see that the file has been set to executable. Now I can decide to add, commit and push in this directory, but remember that we made some changes in the ALX-low_level_programming_1 directory as well. We created a readme file, so I can simply go back to this readme file and then do my add, commit and push in order to push all of the content at once. I'll clear my screen once again. I use the syntax cd ... to go back to the ALX-low_level programming directory. So at this point I do my git add, I do my git commit. Now my commit message, I'll simply call it task 0 and task 1. Okay, so you would see that the readme file is added. The readme file in the hello world directory is also added. The one-compiler in the hello world is also added, and the zero-processor file in the hello world is also added. Then I can push. I have successfully been able to push. Now at this point you can check your first code. At the same time you can check the task 0 and also check the task 1 to see if you're correct. Okay, if you have any issues, you can put your issues in the comment section and I'll be sure to attend to those issues accordingly. Alright, I won't be touching the second task because it's asking you to write a script once again that would assemble. Now to assemble, all you need to do is gcc --s, capital letter S is the level of the GCC code that assembles. So you can do that on your own. You can add, commit, then push. Now while here we're asked to write a script that compiles directly, so you don't need to break the process. So to do this one, all you need to do is to write the GCC with no addition in front of it. So just write GCC, the name of the file, then -o, and then you put the output as C is fun. So that should automatically help you to do this particular task. Okay, so I will be doing the next one now. The next one says write a C program. So we will be writing a C program now that would print this word followed by a new line. And take note that what you're printing, there is an open quote here. There's no closing quote. So it means your output program must display the open quotes, and programming is like building a multilingual puzzle. Now you are to use the puts function, and we are not allowed to use the print function yet. and at the end our program should end with the value 0. So it means our program needs to return the value 0. So once again, I'll copy the file name. Okay, so I'll have to return back to my 0x00 hello world directory. So to do that, very simple. All you need to do is just use cd space dash. So that should take you back directly to your 0x00 dash hello world directory. I'll list the contents of the files. Okay, so let me clear my screen at this point. Okay, so I'm trying to create a C code. You would see that the file is /puts.c. This .c helps you to identify, or helps the shell to identify that you're trying to write a C programming code. Okay, so I am inside my VI, I to insert. Now, how do you identify your C code? You must import the stdio directory. Sorry, the stdio library. So you start with a hash, and then you include, you use the less than, then you bring in your stdio.h, which is a standard header for your C programming language. Now take note that in your C language, to write your C code, all of this must be written first. So your after including your stdio.h, which is the header file for your C, you must write all of this, and then the body. This contains the body. I'll show you what I mean gradually. So this is the header that you've written now. The next thing you do, give 2 spaces, that is, you press enter twice. You start with the, as indicated here, with the /, 2 stars. That shows that you're starting a comment. Enter. Main. Now for your main, this is the, you call it the entry point. Sorry, after the dash I should have the space before the E. Okay, so you have your entry point, 2 lines once again, then you write return. Now what are you expected to return? Always 0, to show that that code was success. Sorry, there should be no star before success. Success. Then you close the comment. Close the comment. Now, so all you've done is you simply inserted a comment of what your code is supposed to do. So you're saying main is the entry point where you begin to insert what you want your code to do, while the return shows you that, okay, the code must always return a 0 in order for the code to run as successful. Then you close the comment. The next thing now to do is to import, to insert the main. That is, the main is what should contain your code body. So int main void, enter. Then you use your color brace to show that that's the body of the code. Open and close color brace. Okay, to make it easy for you, just use the open color brace, enter. Now at this point, it means we want to begin to write into the body of the code. So what do we want the code to do? From the task page, we are told that the code, that's task 4, we are told that the code should print the statement, programming is like building a multilingual puzzle, with the open quotes, using the puts function. So how do we do that? Alright, it's quite easy to do that. So all we need to do is type in puts, which is the function we're expected to use, an open bracket, open quotes, that is, you want to tell puts what to print. But take note that we have an open quotes before the P. So how do we avoid, how do we tell C that that open quotes is part of what we want to print? We need to escape it. So we use the escape syntax, and then we type in our programming is like building a multilingual puzzle. It's like building a multilingual puzzle. After puzzle, nothing else. We close the quotes and then we'll close the brackets. Now after closing the brackets, you would see that the bracket close shows that it matches the bracket that was open earlier. We put a semicolon there and we'll move to the next line. On the next line, we need to return 0. Now take note that after my return, I added a space before 0 and then your semicolon. Now the space here helps you to write your code in Betty style. If you put the bracket immediately after the return, by the time you check your code, Betty will tell you that there is an error. Also, to make my code more readable, after this I can put one more space in between just to make my code more readable. Okay, so after return, what do you do next? I can go 2 spaces down and then I close my code using the closing curly brace. You see that the closing curly brace matches the one that was opened earlier. Now after doing this, what is next? Escape to quit. Escape to go back to command mode, then column WQ to save and quit. Now I have successfully written my code, but if you do git add, git commit and git push at this time, even though you have written the right thing, your checker would still come back and spin wrong. So the next thing we need to do, we need to compile. We need to compile this code. So how do we compile this code? Very simple. GCC, the name of the file when we're trying to compile, -O to specify what the output should be. I'm going to give the output to be 4 puts, but the .c needs to be removed. So if I press enter, nothing displays. But if I do ls, you'd see that I have my 4puts.c, which is my C code, and I have my 4puts, which is the compiled version of my 4puts. But you see it's showing color green, which shows that it is executable. So I can decide to run that code now, 4-puts, to see the content. Okay, so you get a bunch of stuff, and then anyway the output needs to be there somewhere. Okay, clear my screen. So after clear my screen, let me do an ls once again. Okay, so at this point I can git add, git commit. Now I use the commit message. Oh, sorry. So I do my git add. I do my git commit. Now I use the commit message task 4 and I do my git push. Okay, so at this point I can go ahead and run my code. You can check your code. Now if you check your code and Betty spots some error, all you need to do is try to pinpoint the exact lines. Betty will tell you the exact lines where those errors can be found. So all you need to do is go back into your code using VI and make the necessary corrections that Betty suggests. Now this time around, we are trying to write a C code that will print exactly with proper grammar, blah 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 blah. Now to do this, we're not using the puts this time around, but we're using the printf. So all we need to do is repeat the same process, except that instead of using puts, we use printf. So just replace puts with printf and then repeat the entire same process, and you will be able to solve this one. Now 6 and 7 are two special, okay, 6 is one of the tasks before the advanced tasks. Now C says you need to write a program that prints the size of various types on the computer it's compiled and run on. It's the same process that you need to do, the same process as we did earlier. The only difference is you need to type in the files according to how it is displayed here. Okay, so let me quickly do that for you. Okay, so vi, the name of the file, once again, I to insert, hash include stdio.h, start with my comment, main entry point, return always 0 success. Okay, so I need to close my that, int main void okay, open color brace. Now from here, what you need to do is you need to type in the same way that you're seeing it being typed here, size of a char. Okay, so I'll do printf size of a char. Okay, so you see there is a colon in front, size of a char, %lu, that would help you print the size of a char, %lu. Okay, so you have byte or byte into bracket s. As you can see, I'm following these steps. Now the figures 144 is going to be provided by the lu. Okay, so I do that, sorry, /n, comma here. So we move on to the next one, size of char. Yeah, and that's followed by that and goes to the next line. Okay, now I just remembered something quickly. Now for the scripts that we wrote earlier, the scripts would not have any issues. Now the first code we wrote here, you would, by the time you check your code, you would have an error. So I'll fix it, and I'll help you see how to get it right. Okay, so this is what we have to do. Repeat the same process for the rest of the other files. So let me just do this quickly. Let me take out this space here. I want this to be redundant. And I'll have return space then 0. Okay, so let me make the necessary adjustments. So after char we have int. Okay, so change this to size of an int, and this will be size of int. Then after int we have long int. Jeez. Okay, so after adjusting the files accordingly, this is what you should have at the end of the day. Now take note that when you want to do your task 5 using the print statement, ensure that at the end of the strings you're trying to print, you use a \n, but for the puts we don't need to use a \n, but for the printf statement we need to use a \n at the end of. By the time you write at and a comma, you need to introduce a \n. Now take note that to be able to so you put a \n at the end of the string. Now, so we're currently on the task 6. So after doing it right, escape :wq to save. The next thing you need to do is to run your compiler for the file, the output. I'll call the output 6 eyes, and then run that. You'd see I have my 6 eyes code and I have my executable 6 eyes. So at this point I do my git add, I do my git commit, I'll call that task 6, and then I do my git push. Okay, so that is done. You can then go ahead now and check your code. So for task 7 and task 8, to be able to do this task 8, I need to introduce to you a new technique. Now for our task 8, we would need to use the unistd.h library. In C and C++ programming, this is Wikipedia. The unistd.h is the name of the header file that provides access to the POSIX operating system API. Now in the POSIX operating system, we use our input output arguments are read, write, and close. Now why are we going through this process? The task says we're not allowed to use the printf or the puts statement. So the only alternative we can go ahead to use is the read, write, close. So we're going to be using the write. Now if I click, if I try to find out information about the write, excuse me, the Linux manual page open. Now to use the write syntax, it is followed by a bracket. Now in the bracket I must provide 3 information. I must provide an integer, which is fd. I must provide a constant, which is the buffer, and I must provide a count. So 3 inputs must be provided when I use the write syntax. Okay, so to run this file now, we are told to write a C program that will print exactly this word without using the printf or the put statement. So I copy this now. I vi the name of the file. Okay, so I use my eye to insert and I begin to type. Alright, so this is what you should have. Now I have included my stdio, which is my standard C header. I've also included the unistd.h, which is the header that introduces our POSIX programming. Now this is the comment or the body that tells us, the comment that tells us what the body of code should do. Now what is the code supposed to do? The code is supposed to print exactly. It's supposed to print exactly, and that piece of art is useful. And now for our code, we want the code to return 1, because from we're told that the program should return 1. Okay, so you can change this to always 1 success, or you leave it as always 0 success, whatever the case may be, you're fine. Now once again we do our int main void. So now the 2 here represents the initial integer that is provided. Now write up to count byte from the buffer starting at buf. So we're telling the write to count the buffer starting from the second, that is after the comma. So we move 2 steps forward and we start counting. So it's going to start counting from here and begin to print till it gets here. And then we're expected to return this as our output. :wq to quit. Once again, I have to compile the code. I'll use the, I'm supposed to compile the code 101-quotes .c, and my output should be 101-quotes without the C. Okay. let's see, do I have the file? Yes, I have the file. So GCC 101. Okay, I wrote quotes, quote dot c, not quotes, dash o 101 dash quote. Okay, so it's compiled successfully. This is the output of the compiled file. To my git add, my git commit. I use the commit message advance task 2, then I push. So at this point, after pushing, you can successfully check your code, and if there are any issues with Betty standard, all you need to do is check the lines that Betty has issues with and try to fix those lines accordingly. Okay, that will be all in this tutorial. Please do well to subscribe and give a thumbs up to this video if you enjoyed it. If you have any questions, you can drop it in the comment section and I will sure attend to it as soon as possible. Alright guys, I'll see you next time.